All right, so we're on the quotient rule now, right? You've done the product rule, you've done the power rule.
When did we do the power rule?
Yesterday. That's what I just showed you in the warm-up. So basically what we're doing is learning how to calculate derivatives, right?
I thought what you showed us on the warm-up was the product rule.
It was.
Is that power rule, product rule, same
Oh,
thing?
power rule.
Yeah.
No, product rule's different. Montaigne, you
Power
weren't
rule,
here.
product rule. Well, when we learned the power rule?
Yes.
Last week.
Yeah, okay.
Yeah.
So
That was at least Thursday.
the quotient rule is very similar to the product rule, thankfully. There's just a couple minor differences, right? So, is that a quotient? Yeah, it's a division problem, right? Okay. So I'll go straight into the conceptual part here since we were okay at the product rule. There's a nice little jingle we have for this, so it's easier to remember.
Oh, no.
Okay, but it's the same top as the product rule, except there's a minus. All right, so we're going to derive the top, copy the bottom, right? Copy, derive copy, but it's a minus now, and now we have copy derivative. Okay. Oh, we're getting there.
Okay.
I'm no George Strait, but
You sound
it's a
so
good country
menacing.
jingle.
You sounded so menacing when you said that.
Okay, and then the difference here is it's a quotient. The bottom squared.
So it's derived top, copy, bottom.
Minus. Yeah. Okay. Let me get that written down, then I'll start singing.
Oh, yeah.
Okay, so if you can come up with one of these for the product rule, I'd greatly appreciate it. But here's the little saying: it's low, D high. So right, low, D high, derivative high, minus high times D low, right? High D low, over the square of what's below. Okay, this is how you remember the quotient rule. We'll make that one W. Low D high minus high D low, the square of what's below.
What does low mean?
Okay. The low function is this one, and the high function is this one. So you would take the low times the D high minus high D low over the square of what's below. Okay. You like it or you don't like it? Okay, I thought so.
I have too many other ones jingles.
Oh,
Jingle bells.
No? I just got used to it being Halloween month, please.
Oh boy.
Christmas songs wait till after
Okay,
Thanksgiving.
so there's
Christmas
the
songs
conceptual,
wait
like
till
the quotient rule there, and then the little jingle. So let me give you a few examples. All right, so probably will clear up any questions you might have, and how to calculate a quotient, derivative of a quotient. Good? Okay, let's say that some function is e to the x over x squared, right? Calculate the derivative.
what's the derivative? So
Were you gone last week for the power rule day, or are you just
I don't know.
gone mentally for
I'm
the...
running the struggle bus on chapter 3. So that would be e to the x.
Okay, so low, d high, right? minus high d low. What's the derivative of x squared? Okay, over the square of what's below? Yeah, which is x to the fourth.
So would you write x to the fourth?
I would write x to the fourth. I just put that there to make it obvious. Okay?
For the one that you showed us in the last slide, why was X in the front?
It doesn't matter.
Oh, okay.
So a couple ways to think about it. One, the low d high minus high d low over the square of what's below. That's one way to think about it. The other way, and this is how I memorized it when I was your age, the top is the same as the product rule. That's why I put it in these two in different order here. Okay, because the product rule is derivative first, copy second, copy first, derivative second, right? So either way to memorize it, it's fine. Most people use the derivative jingle, which is what I use now. It's just so much easier to remember. Okay. Okay, if you're on a free response question, this is a perfectly acceptable answer. No touchy. Okay? But if it's not, and it's a multiple choice, you might have to simplify algebraically. Okay? So is there a common factor up here?
Question, isn't x squared just copied though? It's not,
Yeah.
but isn't that supposed to be the derivative in the front?
It doesn't matter. You can write this e to the x times x squared. It's the same thing.
Oh, okay, you just switched it over.
It doesn't. It's they're commutative. Multiplication is commutative. So take your
I heard that's the three different ways.
what?
I heard commutative, quantitative.
Commutative. Think about it this way.
His way's right.
When you come to school, you start at your house and you come to school. When you go home, you start at school and go to your house. It's the same route, correct? You're just traveling different directions. It's the same distance. Commutative. You're commuting. Okay, what's left in the parentheses?
X times x.
X minus 2. Because I pulled an x e to the x out. So x is left here, and 2 is left here, right? Can I simplify more?
How do you get the x e?
Well, it's just common terms. There's an x and an e to the x here, and there's also an x and an e to the x here. You're just factoring. Right? And then what's left is what you write in parentheses. I can simplify one more step. Anybody see it?
Take out an x?
Yeah. X over x to the fourth, you can eliminate one x, so. Okay, so that might be something you need to do. So when you're doing your assignments, always simplify to practice your algebra skills. Okay? Always, always, always. I got a song stuck in my head now. Bummer.
Yeah, bummer.
You can go home
Sure.
and start working on stuff and I'm gonna do
I probably will be working on the farm tonight.
And just singing I Will
Humming.
Drive in your head all
Yeah.
day.
Okay, find the equation of the tangent line
Oh. There you go.
to the graph. Yeah, these can get wordy. The f of x equals that's a cube at x equals 1. Yeah. So, okay, we can't simplify it. Well, you could simplify this. It's just a really nasty synthetic division problem.
I don't want to touch it,
We're just going to do the quotient rule
please.
and call it a day, okay? So, okay, we're writing an equation of a tangent line. What do we need? Slope and a point, right? So we can do f at 1 first. It's easy. Whoops. Anybody disagree? Nope, me either. All right, now derivative, right? We good? Plug 1 in. 3 plus 1 is 4, minus 2 is 2. 4 plus 1 is 5. The point. Okay, derivative.
Derive top. So with
So do you like the jingle better, or do you like just the formula? Okay, so low, copy low, right? D high is just a power rule problem. No? Check your math there. Learn how to multiply. What's the derivative of the top? Plus 1. So low D high minus high. Derivative low is, Damon?
Oh, 2/5. I don't know.
Derivative bottom.
Oh, yeah, 12x.
Okay, are we good with those derivatives?
Yeah.
Garrett, you look confused. What's the problem?
Isn't that to the 5th, right? But that's to the 3rd, that's why I'm confused.
Oh, okay.
The 3rd, okay, I'm good.
Over the square of what's below, right? Low, D high, minus high, D low, over the square of what's below. Okay. And now we get to do the fun part where everybody screws up.
Yay!
The derivative's easy, right? Now plug 1 in and get the slope. F prime at 1.
That's why we have calculators.
Yeah, they're called brains, you know? Like, okay. So plug 1 in, you get 5, 7. That's, we know is 2, right, from above. 12, and
25.
we get 35 minus 24. 11. Correct me if I'm wrong there. All right, write your equation, and then we'll check it with mine.
So before I the power rule is where if you have 3x squared, the derivative of that is 6x. Yeah? Oh, okay.
So you want like 11/25 of that equation?
Yeah, 11 is just low.
Do you have to?
No. That's
What does this represent, Damon? Slope. Yep. And then your point,
is 1.
1 2/5. So the equation. Okay, keep going.
11/25 times x minus 1.
Don't make it too obvious. Okay.
Yeah, I actually boiled all those out. So I got really fast. Minus a. So whatever number you plug in. You know what I mean? You plug in 1, the 1 goes in.
Are you good? Are we okay with that?
Oh, without the money. Yeah. That's what the thanks loan.
Okay. Well, I just want to make a notational.
This is not, you have to have. So that's what's one. We'll find that as one. Yeah, so then you plug that in there. It's already there, right? That's Tuesday. Yeah. Those two F9. No. Where did you plug this in? What did we do?
This is the other way to notate derivatives, right? Leibniz notation. Notice from the video it said Leibniz in it. He's a pretty influential guy. What does this mean?
So for x of 4.
Yeah, it means calculate derivative. Yeah. I won't drag you through the mud on that, but calculate derivative, plug 4 in, right? Okay, sounds like you got that. Okay, that's all I've got.
Yeah, but you don't put that.
Do you want me to write the homework down again? Okay, 3.3 product rule. 1, 2, 21, 40. Quotient rule. 7, 10, 33, 39. And then there's spiral.
Let's say PR.
Yep. Product rule. Quotient rule. Right.
Well, I was thinking, Jeff, what does that mean? What are you saying about that?
This notation, that would be the same thing as saying calculate the derivative of 4. Right, so on the last slide, f prime at 1, I could write this also as derivative f with respect to x equals 1. These mean the same thing,
Okay.
just a different way to write it. Okay, good? All right, so you have like a half an hour. Take advantage of that. I give you that time to encourage you, especially you seniors, go to the financial aid night tonight. It's a long-term benefit. Okay?